networks come into play. Other than that, the urban congestion is increasing and we have the limited road capacity. So, the very optimized way of traffic routing should be there. So, in that manner as well, we need the vehicular communication. The third thing is the URLLC communication. The ultra reliable communication should be there for autonomous mobility. If the autonomous vehicles are communicating with each other, it should be very reliable communication, and along with that, very low latency as well. Okay, so shift towards ITS, it is the same thing. We are actually moving towards the intelligent transportation systems. In that, 5G V2X is one part from the communication networks. Then the 5G as a catalyst, we are working on it. We are taking the 5G in vehicular networks. So with that combination, we have developed 5G V2X, okay, for low latency and mission critical communication. So finally, means the overall, what is the motivation? Since the vehicles are transitioning from isolated mechanical systems to fully connected computing platforms, the connected vehicles help reduce accidents through cooperative awareness messages, okay, improve mobility through real-time traffic coordination, and enable advanced driver assistance systems. So this is why we work upon the vehicular networks. And finally, 5G V2X, it will shift towards 6G V2X and so on. But currently, we are working on 5G V2X, and we have still a lot of problems in that. Okay, that are yet to be solved. So these are the basic communication modes. It is there in 5G V2X and the previous versions as well. So here primarily there are uh, some pedestrians are there. Okay, let me switch on that pointer. Okay, so we have in the vehicular networks, we don't have only vehicles. We have vehicles as well as pedestrians, as well as the cellular network towers and the local towers, which we call the roadside units. Okay, so these all things are there in the vehicular network. So we use different methods for the communication among these things. Like V2V communication needs some has some different requirement than the vehicle to network the communication. So that has a separate requirement. Vehicle to pedestrian might be having some different requirement. So pedestrian to network might be having some different requirements. So collectively, it is called V2X communication. But yes, the requirements for every communication are slightly different. Okay. So this is the evolution. So you might be aware if you are working on this area, it all started with the vehicular ad hoc networks. That was the standard for that was 802.11p. It was the standard for physical layer and MAC layer. Then it continued. Then we proceeded towards the LTE V2X. Then we are moving towards the 5G V2X. So currently the release 17 and 18 are there. So in release 17, a lot of features of 5G V2X, lot of advancements of 5G V2X are provided. Okay. Yeah, but still there are a lot of things which are only provided. The requirements are provided, but how to uh, achieve efficiency in that particular area is not given. So that is where our work comes into play. So this is our work to whatever the 3GPP has provided the standard. So we will have to further provide some amendments, or we have to some protocols we have to provide so that the communication is more efficient. Okay. So if somebody has not worked on the 5G yet, so this is a simple diagram that is given by 3GPP only. So here, why 5G is used means how the 5G, what are the performance parameters that the 5G should be able to should achieve. Okay, so the this small area is for the 4G. This is for the 5G, the big hexagon type. This is for 5G. So in terms of vehicular networks, we primarily focus on the mobility. Since the mobility of the vehicles are very high, then the latency, since the vehicular networks sometimes need to send emergency messages like the accidents one or some alerts on the road. So for that, the low latency is required. The connection density is not that much, yeah, in terms of vehicular communication. It is for the IoT and the yeah user experience data rate also we take care, and the spectrum efficiency, it is there in everywhere, in every domain. So in V2X, primarily mobility and latency are our concern, and this one as well, the experience data rate. So to achieve this, we have to provide some way, or we have to provide some protocols to achieve this much. Up to means so far 1 millisecond latency is not achieved in uh, uh, real world. Even in the simulation, if we allow a very simple network, then it is fine. But in the real network, in the simulation, we have not achieved the 1 millisecond of latency. Latency, means I hope you are already aware of it. Latency is the time between the message reception and the message transmission. Okay, how much time the message is taking from the receiver, from the sender to receiver. So in vehicular communication, it should be very less. So 5G V2 and 5G V2X, we try to achieve 1 millisecond latency. Okay, but obviously it is difficult to achieve. Yeah, but we are trying for that. Okay. And when the mobility is high, obviously our network performance degrades. So we have to take care, we have to modify our protocols in such a way so that the effect of mobility is not very high. Okay, okay, please let me know, am I audible? Somebody please speak. Hello, am I audible? Okay, okay,
You are audible, sir.
okay, okay, that is fine. Okay, so these are the layers for vehicular networking. We primarily conduct research in this area. Okay, we primarily conduct research in MAC layer, physical layer, and network layer. Okay, so I will discuss briefly about what changes or what are the research challenges in all these three layers, and what we can do or what tools we have to solve these problems, solve these challenges or tackle these challenges. Okay, so I think my slides froze. Okay. Okay. So before going into the research challenges, if you have worked in this area in any simulation of any type of network, when you have, if you have tried, you must have faced a lot of difficulty. Okay. So the simulation of the network protocols is very difficult. So for that, the best tool that was available earlier was Network Simulator 2. Now it is not used. It was not updated after I think 2012. So now we use Network Simulator 3. Okay. So in Network Simulator 3, it is very good tool, and we can actually simulate a lot of things, whatever we uh, do in the area of the networking, whatever protocol we propose, almost everything we can do in this tool. But yeah, the latest technologies, obviously, it is the NS3 doesn't support all the latest technologies. So what happens when any latest technology standards come out? So the developers start developing the patches for that. So currently, we will stick to our domain only, the 5G V2X communication. So for that particular domain, currently we use NS3 only for means authentic simulation. We can use MATLAB as well, as you know, but in MATLAB we have to design the analytical equations, means the mathematical equations first, then we have to analytically analyze. So complete simulation is not possible in the MATLAB, like event-driven simulation. Okay. So the actual packets are not sent in the MATLAB. It is done in the simulator like Network Simulator 3. So it is uh, actually expected to simulate whatever you have proposed in at least one simulation tool. And if we try to, you might be thinking that we can actually use some hardware for our protocol evaluation, the performance evaluation of the developed protocol. But obviously, hardware is actually very costly, and in especially in terms of vehicular networks, how you are going to run the experiment. You can't run 100 vehicles in an area, and you have to means you have to have a lot of funds for that. So obviously, NS3 is a actually other middle path for that. Yeah, but it is very difficult. Okay, if you have any of you have tried it, it is very very difficult. But yes, yeah, we can find a way out of that. Means we can find a way to simulate our protocol. Yeah, so most of the simulation tools do not contain all the features. Obviously, any of the simulation tools don't contain all the features. Why? Because the features which are being developed for 5G are new, so it will take time. So currently, this NRV2X module, I have given the link if you want it later. So you can use this link, and that particular patch is the best available. It comes with the NS3 everything, so you can just directly install it. Okay. So it has 5G NR side link support as well. So side link support means the direct vehicle to vehicle communication. Okay. So it implements vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, every type of communication. Okay. So it supports side link, physical and MAC layer, resource pools, semi-persistent scheduling, everything. It enables simulation of mode 1, GNB scheduled, means with the help of the network, and direct vehicle to vehicle communication as well. So that is mode 2 in the that release 17 of 3GPP. So it provides realistic channel propagation Doppler. So it has actually many features. It allows modeling of safety messages, platooning, cooperative perception. So many features are there, but yeah, obviously it is not the complete one. Okay. So it is continuously being developed, but yeah, it is there. Means you can actually simulate your method on it. It might be a little bit difficult, but yeah, once you simulate one protocol, then you will be used to it. Now, after that simulator, we will again come to the simulator, because whatever I am going to tell you today, whatever challenges that you will be actually simulate, means that you can actually solve and simulate in the particular tool. Because if you develop a method and there is no way to simulate that, then how you are going to analyze? You are not going to actually justify your work. So so channel related challenges are like beam forming requirements. I hope beam forming is well aware of, you are well aware of beam forming. And nowadays in MIMO systems, we don't transmit omnidirectionally. Okay, so the waves are actually directed towards the receiver. So that is called beam forming. So the beam forming in vehicular networks is very difficult. Okay, because vehicles are moving. Okay. In your home, you have air fiber. In that case, the beam forming is easy, because what happens? Your that receiver is static, your transmitter is static, but in vehicular network, it is very difficult. Okay, to create a beam that points towards your receiver. Okay. So this is one research challenge, and you can work upon it. So I also worked up on it on this area, means for only for a few months. But yeah, then I moved towards other areas because it was more focused towards the physical layer. So my research area is probably mech layer. So yeah, I moved from it. But yeah, you can take it as the research challenge. Then the high Doppler spread, obviously due to the higher mobility, the Doppler spread is high. Then multipath feedings occurs, okay, in tunnels or intersections. Multipath feeding, I think you know it very well because it occurs everywhere in the real networks. The shadowing from buildings and large vehicles, these challenges are there. Means from these means how you overcome the effect of these things, the severe multipath feeding, the shadowing, and rapid topology changes. How you overcome the effect of these things is the challenge. Okay, so rapid topology changes, since the vehicle moves at a higher speed, the topology changes, okay, in even in a few seconds. Okay, so one vehicle is continuously coming towards you, and then it suddenly turns. Okay, so one vehicle is, or five vehicles are means the running on one highway, and suddenly two turns to one another another that road. So the topology changes rapidly. Then line of sight to non-line of sight transition. That's for same way, like in the urban area, this phenomena happens a lot. So currently you are in the line of sight of one another vehicle, then the vehicle turns to another road, and then suddenly it is out of your sight. So all these things look simple because we have read these terms since our UG. Okay, but when you actually simulate these, the effect of these effect is very very severe in vehicular networks. So you have to take care of these. How you are going to solve these, that is up to you. Okay, so these are the challenges. Now, what simulation is feasible in NS3? That I am going to talk, because most of you are faculty members, so you may take it as because I mean, you know already. If you are from some networking domain, obviously you might be knowing the theory. Okay, my objective is I can give you some research problems and the some path or the direction to solve those problems so that you can proceed ahead. Okay. So the beam forming, the NR module, this NR module, it supports directional transmission and per link SINR, means SINR calculation for each link. So we can change the antenna patterns, beam choices, and update them based upon position or SINR in your script. So its simulation is relatively easier, but yeah, if you start from the beginning, obviously it is not that much easy, but yeah, you can do it. Currently a lot of examples are there with every. In NS3 the support is very good. In NS2 when we used to work on network simulator 2, the support was not good, but in network simulator 3 the support is good. Yeah, there are a lot of examples are there, a lot of comments are proper in the files, so you can actually take a help. Okay. So the Doppler aware link adaptation. So high mobility and Doppler are already modeled in NS3. Not NS3, actually LS3 with this module. So when you download from the link given, you will be downloading the complete one. Okay. So you can log SINR over time and implement algorithms that adapt MCS power or resource selection based on predictive channel quality. Okay. So you can log SINR, signal to interference noise ratio. So you what you can do, you can log it, and based upon that data you can design some algorithms to actually implement algorithms. Okay, design some algorithms to actually implement to adapt your network according to these parameters. So you can change the power requirement, the modulation and coding schemes, the resource selection, which resource is to select on the predicted channel quality. Okay, so these things you can do here. Then the RSU is actually the roadside unit. In the previous slide, we saw this one. This is the RSU. This is your vehicular network. This is the RSU. A roadside unit. It is a general term in vehicular networks. So roadside unit placement, density and height optimization. So what we can do for a particular location, there is actually a tool named Sumo, Simulator for Urban Mobility. Along with that Sumo, I should have kept it here. But you can remember it if you are working on it, working in this area. So along with that Sumo Simulator for Urban Mobility, we can use one website is there, that is Open Map something. Yeah, I forgot the exact name. So means combining those, what you can do in anywhere in the world, you can pick a particular area and you will get the traffic model of that particular area. Okay, so I think that is openstreetmap.org. That is the site, and along with it you can use Somos to develop a scenario that you can directly use. So for that particular scenario, you can optimize where the RSU need to be placed, the roadside unit, that what is the density of this or other vehicles, and the height optimization of the antenna and everything you can place. So in V2X, obviously only RSUs are not there. The 5G is there. So G node means the that base stations of the 5G also you can keep, and you can actually calculate whatever the performance parameter. Mostly two performance parameters are uh, important. First one is latency, that is the delay, and the packet delivery ratio. How many packets are being lost in the channel, or how many packets are being successfully received at the in the network. Okay. Then the fourth thing is relaying via other vehicles. So these all things we can actually do. I will also tell you what you can't do in current version. Okay. So relaying via other vehicles or UAVs. So you can create intermediate nodes and forward packets in the application or network layer to simulate relay base. Relay means if in case of line of non-line of sight communication, you might need to forward the packets through some other vehicle, or it might be some roadside unit, or might be UAV, something like that. So for that purpose, that is also possible in it. So relaying is there. How you relay, how you going to select a particular node for relay, that is your means up to you. Okay, what parameters you are going to apply, you are going to use, what method you are going to apply, everything you can decide, and you can implement that algorithm in this module, and you can finally get the performance. So once you means how we actually make our network efficient, at once whatever network you will implement, whatever method you will implement, it will always perform worse. So slowly changing some parameters, changing some implementing new small rules, then you actually develop, or you improve the performance of your network or of your protocol in that network. So LOS to non-LOS transitions also you can simulate here. Means it happens automatically. You just have to prepare your algorithm in such a way so that it take care of that. Okay. So these in the channel on or in the physical layer you can do. Okay, what you can't do at this point of time, new waveforms such as OTFS or explicit ISAC. ISAC is what uh, that sensing, integrated sensing, computing and communication. It is actually, it is going to come in the 6G part, but yes, we already know it, but it is still not there in NRV2X module. And then RIS behavior. IRS is intelligent reflecting surfaces. It is going to be a part of 6G, uh, where some phase controllable surfaces are there that actually don't let our signal attenuate with the reflection. Okay. So These things are currently not there. So if you want to implement it, you will have to work a lot in this particular uh, module or in NS3, and you have to develop your own libraries for it, okay, or your own files from scratch. But and that is not possible actually. It is possible, but yeah, we don't have as a faculty or as a research scholar even, we don't have that much time that we develop a library from scratch. Okay, obviously we will have a lot of things already available, like notes are there, channel is there, queues are there, everything is there, but yeah, still we can't develop even if we want to develop, suppose the model for RIS. So then we can't do that, frankly speaking. It will take a lot of time, and we don't have that much time, along with the that much knowledge also we don't have. We should have knowledge of the how they have actually developed the NS3. So we should know that, then only we can do. So simply speaking, we can't do these things in the current version of this module. So this module. I am not saying that this module is the best, but as I know, it is the best one. I am using this only. However, it took a lot of time to understand and actually simulate things. Still, we are not perfect in it. We are still trying, but yeah, it is very good. Okay, now the spectrum and interference challenges. So there is a lot of congestion in 5.9 gigahertz band. Since uh, even many techno like even the Wi-Fi 6 is working in this band only, nearby this band, nearby the spectrum that is allotted to the vehicular network. The Wi-Fi works adjacent channel is the Wi-Fi one. So it causes adjacent channel interference. So in 5G, 9.5 gigahertz band, we don't have a lot of bandwidth allocated for the vehicular networks. Okay, this is one thing. So there is difficulties in spectrum sharing. Spectrum sharing is actually another thing that is not that is like the cognitive radio networks, if you have heard of. We actually share the spectrum with the nearby bands. So that is a thing that is difficulty, and interference between V2V and V2I communication is there. So these are the spectrum and interference challenges. So what is feasible in this one is, what you can do is, uh, this module supports multiple carriers. Okay, so multiple carriers, even you can use two bands simultaneously, like sub 6 gigahertz and millimeter wave as well. Okay, and implement policies that move some traffic to another carried based on load. So you can use both. Even on one node, you can apply two interface, one of sub 6 gigahertz, but one is of millimeter wave. But obviously, you will have to check its feasibility and in real world, whether it is required or whether it will increase the cost a lot or something like that. Okay. But in simulator, yeah, obviously you can do implement the policies that move some traffic to another carrier based on load. Okay, so these are some ideas that you can work upon. So separate pools for B2B and B2I interference aware scheduling. So okay, so actually this model is very good in this particular resource allocation part. Okay, so So what we can do here is, the separate resource pools can be there for side link communication. Side link communication is, I told you already, direct vehicle to vehicle communication without the interference or without using the infrastructure like G node B. We don't use that, and we can directly communicate with vehicle to vehicle. And through the infrastructure also we can communicate. So both things are there. Separate resource pools are there. When you study the resource blocks of this one, the resource structure, then you will understand some pools are allowed, can be divided for only V2V, some can be for V2I simultaneously. Okay, so so something you can do, like you can define different pools and choose them based on traffic type. What type of traffic, how you want to send, that you can decide based upon the traffic type, and you can send it as you want. Now the distributed congestion control or power control. So you can change transmit power, packet rate, MCS per node as a function of measured MCS modulation and coding index. Okay, what modulation scheme you can use and what is the coding rate you can use. So these things are there. MCS is a common word in a communication network area. So it is, you can, what you can do, we can change these things. The transmit power. If the uh, receiver intended receivers is very near, we can actually reduce the transmission power. Okay, based upon the packet rate, we can reduce the packet rate if the throughput is not very good on that particular channel. So like these things we can, depending upon our channel conditions, we can actually change these things. So everything, every method that we develop is based on only these small things only, like changing, like if we want to actually optimize the power, energy efficiency we need, then obviously we need to change the transmission power. It should be as much less as we can use. Okay, so like this only we have to work. So other things, whatever you do, either you apply machine learning or you go to the traditional way of solving the problem. So but the final objective is same. Okay, like either reduce the transfer power, reduce the bandwidth use, or optimize use of the resources available, like bandwidth is there, channels are there. So final aim is that only in this network. Then the interference aware make decisions. We can use SINR or SRP measurements from the physical layer to bias resource selection. Okay. So we can avoid resources with high measured interferences. So if the SINR is high in a particular resource blocks continuously, this resource block continuously, so obviously we are not going to use that particular block. Okay, in the subsequent uh, these time blocks. Okay, so these are the things we can do. So currently the cognitive radio is not supported. Cognitive radio is what? The using the bands of the nearby technologies like Wi-Fi 6E. We can't use that. Means that we can use, but currently with the vehicular network, it is not supported. Okay, the separate cognitive is there, but yeah, with the vehicular one, don't have the flexibility. Okay, and a network simulator too, it was there with vehicular networks, but obviously this was a long way back. Currently, for in 5G V2X, the cognitive module is not supported. So you might be facing some difficulties if you want to simulate it. Means difficulties means you have to again create a lot of things from scratch. So that is not possible. Okay. Then the MAC layer challenges. So platoon aware resource allocation. See, the platooning is very much necessary in vehicular networks. Everywhere, since the starting of the vehicular networks, we are constantly focusing on the platooning. Platooning means creating the groups of vehicles so that the effect of past topology change or the effect of mobility minimizes. Okay. So our this is what, so platoon aware resource allocation, what it want to say is, whatever you, if you want to create a platoon, means the group of vehicle, make in such a way so that the resource allocation is optimized. Okay, so that is the thing. So you can study about the platooning, or another word for platooning is clustering. So these things you can, this is a very good research area you can work upon. Okay. So mode 2 in V2X, 5G V2, mode 2 means that side link 1 in 5G V2X cannot scale under platoons. So this is another challenge. Okay. This is the challenge from my research only, actually. So we can't, when we actually put a lot of vehicles in side link communication, actually our performance degrades. Okay. So, so it doesn't scale properly. Even in mode 1, like with the infrastructure also, the performance degrades, that is true, but not that much. Okay, so here performance degrades rapidly. Okay, then the adaptive scheduling means there are a lot of messages, lot of types of messages. Like some messages might be very important, some might be less important, some might be not that much important, and some messages might be like that. Whether it is received or not, it doesn't matter much. Like the entertainment type of message. Okay, so in adaptive scheduling, what we have to take care in our method or in our algorithm, whatever we have developed, it should be in such a way that the important messages should be scheduled properly. Along with that, there should be a fairness aspect. Like if any message that is not very important, it is less important, and there are a lot of means very important messages, so there should be some fairness. It should not be like that that only very important messages are being transmitted continuously. Okay, so this is adaptive scheduling. We should work on it, and there is a lot of scope in this area. All these three, there is a lot of scope. Then the fourth one as well, the lack of dynamic prioritization. For it is almost same thing. Then in adaptive scheduling, it is the same thing. The dynamic prioritization. We need to prioritize our messages. After that, only we can do the adaptive scheduling. So along with this dynamic prioritization, what we need to do is we need to actually do some preemption as well. Preemption in networking means the message that is there in the queue. A vehicle transmits the message by eliminating them from the queues, taking it out from the queues. Then what happens in the preemption, the queue is there, but if any message that is very important, we have to take it out and should transmit immediately if its deadline is about to come. Okay, so these things are there. Like suppose if okay, I'll give you an example, either or it might be a more that theoretical. See, suppose uh, you are the two vehicles are moving, and two autonomous vehicles are moving. So the distance between those two is suppose so maybe 10 meters, and suddenly the vehicle that is in the front collides with another vehicle or some object, and it stops immediately. So what is to be done? The device or the transmitter in that particular vehicle that has been collided should inform immediately to the vehicle that is only 10 meters behind it. Okay, so in that case, the preemption is there. Preemption should be there. Means that message. Suppose there are already 10 messages in the queue of that particular vehicle, and that message comes. It will be the 11th message. But obviously, due to its high emergency, means the high priority, it should be transmitted immediately. Okay. Otherwise, if it is transmitted after the collision, nothing. After the vehicle that is behind is collided, so that is not good actually. We don't want that. So that is why the preemption is necessary. So in foggy weather, in like in the winter season, due to fog in the on the expressways, we see these type of incidents every year. So where when the one vehicle is collided to another one, we see 10 to 15 vehicles are continuously colliding with those vehicles. Okay, so these are the challenges. So this particular module is very much flexible for these features actually. So we can actually do that is mode 2, that all side link algorithms we can develop, we can implement, we can develop with the we can use a lot of parameters in that. Okay, so including the RL ones as well. Okay, then the platoon aware resource allocation is also possible. Actually, I work in this area only in the Mac layer on this one, so that is why I am quite confident in it. So adaptive scheduling we can do here. It was there in Android Simulator 2 as well, but obviously not for 5G V2X. Yeah, okay. Platooning we can do, collision detection and fast reselection. Reselection of the resources is there. Immediate reselection also we can do. But yeah, we have not achieved 1 millisecond latency yet, even in the simulation. Okay. So the priority classes we can define for different traffic type. We can define for different priority classes. We can assign different packets, and based upon that, we can do the preemption or the scheduling. Okay. Then we can offload some traffic to cellular versus side link. So in the side link communication, if some packets are not that much important, we can convert or we can send it through the cellular network as well, using the infrastructure, the G node V. Okay, so that also we can do. Okay, so okay. So what is not supported? This 802.11p is not supported. It is not 5G V2X. It is regular networks. It is the one of the earlier version. I think the first one, the DSRC. So it is currently not used actually. It is there in NS3, but not in this module. Obviously, this is a different technology. So you can find different files for it, but it is not advisable to work on this technology again. Okay, because currently we use 5G V2X. Okay, so for this you need this one. However, don't use it. Okay, so because we are working on 5G V2X, we are not working on 802.11p. Okay. Now network routing challenges. So routing challenges also merges with the MAC challenges. Okay, somehow, because finding the best route, it depends on whether the channel is free or not, and the channel is free or not depends upon the is the work of the MAC layer finding the free channel. So topology changes too fast for traditional routing because vehicular network is too fast. Means the changes too fast. The topology changes too fast. The delay sensitive routing is complex. The delay sensitive routing, like you want to transmit a very low, when very low latency, it is very complex. Okay. So ensuring reliability during handovers is difficult. Okay, if currently you are in communication with one G node V, then uh, in the you are now with the working with another GNV, then it is a bit difficult actually ensuring reliability. Okay, so interference aware routing is still unsolved. So interference aware routing is still not there. You can work upon it, but in the network layer, you won't find a lot of resources. Okay, if you want to work in this area, you will have to start from the physical layer and the data link layer or the MAC layer. Then slowly you can move towards the routing. Okay, so here simulation, what simulations are feasible? So the geographic or position based routing is feasible. Okay, so an IPv4 stack we can attach or implement forwarding in your application. Use node positions to choose the next hop. NS3 gives you access to mobility and positions. So cluster based routing is there. So I told you already that the network layer works with the MAC layer. Means there is a lot of support from the MAC layer required. Okay. So that is why here also it is written. So this module works on PHY and MAC. The routing works above it. However, you can still experiment with some ideas. So these are the ideas you can use. So cluster-based routing or the platoon-based routings you can use to communicate. Even in these things we used to do in the vehicular network as well. So currently it is the upgraded version in the 5G V2X, and okay, one more thing is we in this module we can actually use the frequency range too as well. If you are working in this area, sub 6 gigahertz band. Okay, that is 5.9 gigahertz frequency range, and another thing is your millimeter wave band. Millimeter wave is above 24.5 gigahertz to 60 gigahertz, and that particular band also you can actually work. Okay, so okay, so delay sensitive routing decisions are possible, handover over aware multi connectivity is also possible. So these things are possible here. But fully developed interference aware routing with dynamic path optimization tightly integrated with PHY is not supported. But it is not that difficult to that not that difficult to implement, but obviously it will require substantial custom code. So these are the things. Along with this, you can use machine learning. Obviously, machine learning is currently being used everywhere. Currently, a new concept is there called digital twin. Okay, digital twin, I know about it, but how to implement it in 5G V2X is not, I don't know yet. Okay, so that is why I have not kept it here. I kept in these slides only whatever things I am doing and slightly surrounding areas, so that I can clearly tell you, yes, if you go this way, you will find a good opportunity. Okay, so ML, using ML, we can optimize beam alignment. We started work on it, but yeah, I stopped in this on this work. The resource allocation, yes, we are doing. Integrating it with this particular module is a bit challenging because we have to run the Python code separately. Then we have to take the outputs of that to the input. Then again, it's output to their input. So it is difficult. Okay. The another problem with machine learning is we don't have sufficient amount of data. Okay, to train, because a network properties depends on the where we are using it. Okay, so a protocol can be used at the intersection of a urban area, maybe in the some countryside or highway like there. So we have to. It depends upon where we are using it. So data for each of these is not available. Is not widely available. Yeah, some of those are available, but yeah, it is difficult. So the resource allocation can also be optimized. Routing decisions can be optimized. Power control is there. Okay, the predictive congestion control is there. So okay, so these things can be optimized by ML, and these are not the only things. There are many things you can optimize using machine learning. And what you can optimize, the basic will remain same, like the bandwidth efficiency is there, power efficiency is there, many. The basic things will remain same. The you have to efficiently utilize the spectrum, but yeah, how you optimize it, from where you will get the data, that is up to you. Okay, so these are the references I have used. I have kept the slide for 1 hour. These much slides were okay. So I have kept my talk very crisp and direct related to the implementation. So thank you. So in case of any doubts, you can please ask. I am here. Okay, I will open the chat window as well. If you have any doubt, you can type as well if you want.
Welcome, Dr. Prashant. Uh, our previous expert, Dr. Raghavendra Pal, has just completed his session and is waiting for any questions from the participants.
Good afternoon. Good afternoon.
Good afternoon.
Okay, so if there are no questions, we can close. If Miss, you want to still ask me some questions, you can contact me. Okay,
Yeah,
you can
his
contact me
email
through.
ID is available on the SVI NIT Electronics and Communication Engineering Department website, so participants can contact him.
Yes, yeah.
Thank you, Dr. Raghavendra.
Okay, thank you very much, sir.
Yeah.
Okay, so can I leave now, sir?
Yes, you can leave, please.
Okay, thank you, sir.
So, Professor Prashant, are you ready?
Oh, yes, yes. Good
Uh,
afternoon.
Good afternoon. So right now we have about 44 participants.
Okay.
Probably some more would be joining. So let me introduce you to the participants, and then you can start.
Okay.
So for this session, we have Professor Prashant Kumar Sahu. He is a professor in the School of Electrical and Computer Sciences at IIT Bhubaneswar, where he has been working for more than 15 years. His research interests include advanced modulation formats and signal processing schemes, communication system design and modeling, fiber optics device designs and simulation, high bitrate system design, optical communications, optical sensors, photonic electronic signal processing. He has published more than 100 research articles in journals and conferences, and is also cited by more than 1,000 articles. So, with this, I welcome Professor Prashant. It's my pleasure. He's also my dear friend. So, over to you, Professor Prashant.
Thank you. Thank you, Professor Ravi, for the